Let's take a look at this problem. We got f of x is equal to x plus 2 over x squared plus 2x plus 4. Now the first thing, we want to find our domain. Well, whenever you have a rational function, you set your denominator equal to 0. So we got x squared plus 2x plus 4 equal to 0. And you want to solve this. Well, this doesn't factor, so I'm gonna go to my calculator and use the calculator, the intersect method, to do it. So I'll press y equals clear, and we got x squared plus 2x plus 4, and you have to have 0 on y2 or this process doesn't work. So then we're going to do a second trace, choose intersect. Now our answers are where the graph crosses the x-axis or touches it. Well, this obviously it doesn't touch it or cross it, so that means that there is no values that cause that to be true. Well, if there is no values, then it's by default negative infinity to positive infinity. That's our domain. Now for B. B is our x-intercept. You always plug 0 into the other variable, so plug 0 in for y or f of x. So we got 0 is equal to x plus 2 over x squared plus 2x plus 4. Now whenever we have a single fraction equal to 0, you can just set your top part equal to 0. Then take 2 over, and we get x is equal to negative 2. Now our y-intercept, you always plug 0 into the other variable, so we're finding the y-intercept, so we'll plug 0 in for x. So we got 0 plus 2 over 0 squared plus 2 times 0 plus 4. Those zeros all drop away, and we got 2 over 4, or 1/2. And that's our y-intercept. Okay, D, vertical asymptote. Now, vertical asymptote says you factor the top, factor the bottom. We can't do any kind of factoring. Cancel, well, can't cancel, so then we jump directly to setting our denominator equal to 0. So we got x squared plus 2x plus 4 equal to 0. Well, we already tried that in part A. So that means there is no vertical asymptote. Now E, or horizontal asymptote. If your degree of the top, degree is the largest power of x, your degree of the top is 1, degree of the bottom is 2. If your degree of the bottom is larger than the top, then that means your horizontal asymptote is y is equal to 0. Slant asymptote. You only have a slant asymptote if your degree of the top is exactly 1 larger than the bottom, which is not the case, so there is none. Let's see, so we got f of x is equal to x plus 2 over x squared plus 2x plus 4. We're ready for increasing, decreasing, and our mins and maxes. So let's find the derivative of this. This will be the quotient rule. Top part is our p, the bottom part is our q. We need p prime. The derivative of x plus 2 is 1. We also need q prime. The derivative of x squared plus 2x plus 4 is 2x plus 2. Our formula for the quotient rule is p prime q minus p q prime over q squared. So for our derivative, p prime is 1 times q, which is x squared plus 2x plus 4, minus p, which is x plus 2, times q prime, which was 2x plus 2, all over q squared, which would be x squared plus 2x plus 4 squared. Well, let's simplify that up on top. So we got x squared plus 2x plus 4 minus, I'll multiply these two together, x times 2x is 2x squared, x times 2 is 2x, 2 times 2x is 4x, and 2 times 2 is 4, all over x squared plus 2x plus 4 squared. which gives us x squared plus 2x plus 4 minus, combine together like terms, 2x squared, 2x plus 4x is 6x plus 4. Let me double check that. 2x squared plus 2x, 6x plus 4. Yep. And then this stays x squared plus 2x plus 4 squared. Now remember, a negative out in front of your parentheses flips the sign of everything inside. So this negative here is going to flip the sign of that, and of that. So that gives us x squared plus 2x plus 4 minus 2x squared minus 6x minus 4 all over this right here. Combine together like terms. X squared minus 2x squared gives us negative x squared. 2x minus 6x gives us negative 4x. 4 minus 4 drops away. That's interesting. So we got x squared plus 2x plus 4 squared. Now I can factor out GCF up on top. They have both have an x, and the first term's negative. So I factor out a negative x, and that gives us x plus 4 over this. So we got x squared plus 2x plus 4 squared. Now we're ready to find our critical values. So you set your top part equal to 0, so I got negative x times x plus 4 equal to 0, and set your bottom part, x squared plus 2x plus 4 squared is equal to 0. Well, on the right side here, if I drop the squared, we've already tried to solve this 2 other times. X squared plus 2x plus 4 can't be solved. So we'll drop that one. This one over here, though, it's already factored, so I can set each factor equal to 0. I'll set negative x equal to 0, and x plus 4 is equal to 0. Divide both sides by negative 1 here. 0 divided by negative 1, 0. Here I'll take the 4 over, and we get negative 4. Okay, so we're ready for our table of intervals. This goes from negative infinity to positive infinity. Now I'm going to choose test cases, something between negative infinity and negative 4, like negative 5. Something between negative 4 and 0, like negative 1. And something greater than 0, like 1. And we want to plug them into our derivative. Now I'm going to choose this one because it's factored, and that'll be easiest. I shouldn't even have to use a calculator. Now when I got this squared on the bottom, that's always positive, so I don't need to worry about it. I just need to plug it in the top part. So if I put negative 5 in for x, I'm going to have a negative negative, which gives me a positive 5. Negative 5 here, negative 5 plus 4 is negative 1. So a positive times negative is negative, which means this is decreasing. Now if I put negative 1 up here, negative 1 in for x, I got negative negative 1, which is positive. Negative 1 plus 4 is positive. Positive times positive is positive, so increasing. And if I put 1 up here, negative 1 is negative. 1 plus 4 is positive. Negative times positive is negative, so it's decreasing. So this is decreasing from negative infinity to negative 4. And then it's increasing from negative 4 to 0, and then it's decreasing from 0 to infinity. Now I haven't been writing this down, but I guess it's kind of looking like I'm going to have to here. So I'm going to get a piece of paper and write down everything we've been given. I thought this problem would be simpler actually when I started it. Okay, so our domain we said was negative infinity to positive infinity. The x-intercept was x equals negative 2. Our y-intercept was y is equal to 1/2. Our VA, vertical asymptote, none. Or HA, horizontal asymptote, was y is equal to 0. Our slant asymptote is none. And we said decreasing from negative infinity to negative 4. And then increasing from negative 4 to 0, and then decreasing from 0 to infinity. Okay. Well, now we're ready to find mins and maxes. assuming it exists at those places. But remember, our domain was negative infinity, positive infinity, so it exists everywhere. Now this is decreasing and changes to increasing, so this is going to be a min. And this changes from increasing to decreasing, so this is going to be a max. So we're going to have a min at -4, comma something, and we'll have a max at 0, comma something. Now we want to plug those into our original function, which is right here. So let's put that in our calculator. So I'll press y equals clear. The key to graphing rational is you have to put parentheses around top and parentheses around the bottom when you're plugging it in. So we got parentheses, x plus 2, closing parentheses divided by beginning parentheses, x squared plus 2x plus 4, closing parentheses. Now, if you're, I don't remember, looked at this already in this problem. They kind of all running together tonight. But if I go to table setup, if I do second, and then whatever that says, window, your independent should say ask. If it doesn't, down arrow to that line, right arrow, and press enter on ask. Then we're going to go to second, graph, to go in table mode. If you have numbers there, you can press delete to clean them out. And we're plugging in -4 and 0. So -4 and 0. So our min is -0.2. Probably not going to benefit you a whole lot to go more in one decimal place. And the other one is 0.5. So let me write those down. Min is -4, -0.2. And our max is 0.5. We're ready to graph that. So I got everything written down, so let me clear that. And let's see what we got. X-intercept was -2. Right there. Our y-intercept was 1/2, which would be right there. Horizontal asymptote is y is equal to 0. That'd be this right here. So that's our horizontal asymptote. Min is -4, -0.2. -4, -0.2 would be that right there. So that's a min. Our max is 0.5. 0.5. That implies that our y-intercept is our max. That's interesting. I wonder what that means. Well, let's see. We said initially that our graph is decreasing from -infinity to -4. 1, 2, 3, 4. So it's decreasing. And it's going to skim this because it's an asymptote. So it's skimming this, coming down a little bit, reaches a low point here, like that. I know it doesn't go above this because there's no x-intercept over here. Then at -4 it changes and it starts increasing to 0. So now it's increasing, crossing here, increasing to there. And that's our max. And then it's decreasing from 0 to infinity. Now there's no x-intercept over here, so as this is going down, I know it's skimming this. That's what it does with asymptotes. It skims it, gets real close to it, but never touches, never crosses it. And then this is skimming it down below over here. Now that's going to be our graph. Now if we look at this and press graph here, see, it's kind of hard to see. Now we could zoom in. Sometimes that helps. If I do zoom and choose 2 for zoom in. Now once it comes back, you press enter one time. And you can kind of see the pattern there, though really can't see what's happening over to the right or to the left, but we know because we've graphed it already. Now I'm going to do a zoom and choose 6 to set it back. This is where, if we do it by hand, we can get a somewhat accurate picture of it and understand what's going on with the graph. Using the calculator by itself sometimes doesn't truly give us a picture. Now this is the answer I'm going to put in the key, but if you're really good at sketching and so forth, you can come up with even a better graph than what I did right here. Anyway, those are answers.